Good morning. So, excellent. Very happy to see you guys all here. When she was reading the agenda, I just felt like she's going through my talk because all the bleeding edge topics, I hope to cover some of them and give a perspective of what are the top technology trends that we are expecting to change a developer's landscape. A quick correction before I begin. I do not work for Couchbase anymore. As of 2 weeks ago, I work for Amazon Web Services. So I just want to make that quick correction here. This talk that I'm giving, though, is what is my perspective. It's nothing related to what Amazon thinks. It's my personal talk, personal thought process here. All right, so let's get rolling. So I'm literally going to go through a fast-paced introduction for top-down technology trends. It's not the technology itself. It's essentially trends that we are thinking that will change the developer's landscape. Containers is sort of one of the mainstream here. A lot of people have been talking about containers. Every conference you go, every customer you talk to, they're asking like, how do I containerize me? How do I containerize my solutions? How do I deliver faster, more agile way of building and deploying applications? So the first thing that we're going to talk about is containers. So what is it about containerization that makes it so hot? If you look at container, essentially, it's a way to package, run, deploy, scale your application in a completely platform-agnostic way, a framework-agnostic way, or an operating system-agnostic way. Essentially, you take your image, you build, you take your application, you package it as a Docker image. Now, that Docker image contains all of your application dependencies, and then you take that Docker image that could run on a variety of container orchestration platforms. It is completely independent of what operating system you are using, what cloud you are using. You could run, for example, Docker on Amazon. You can run it on other clouds as well. And a lot of different clouds have a lot of different orchestration frameworks. So the idea being, whether you're using Java, whether you're using Node, whether you're using Python, what frameworks you're using, all of those dependencies are packaged together as a Docker image, and then they're run on a container orchestration framework completely independent of the cloud, is what makes this fast. It is also a lightweight alternative to virtual machines. In the sense, if you, like I have a MacBook here. On a MacBook, if I run VirtualBox, with VirtualBox, I could run 2, 3, maybe 4 virtual machines concurrently. It's a pretty decent MacBook. So with a 16 gigabyte laptop, I could run 3, 4 virtual machines. But because I'm running as a Docker container, if I'm running Docker containers, I could easily run up to 50 Docker containers on my Docker machine, on my MacBook here very easily. And that's sort of the beauty of this. It gives you that level of density on how much you can run. Because the memory requirements, the CPU requirements, yes, you can confine them. It uses a minimal operating system as opposed to bundling a complete operating system on top of a host operating system. It hooks into your underlying kernel for doing most of those commands that it would need to get your application running. So that's the reason it kind of gives you that higher density. So why containers? Why does it matter, really? Well, the first thing is, if I were to fire up a virtual machine on my MacBook here, it'll take easily 1 to 2 minutes. God forbid it's a Windows machine, it's going to take a few minutes to fire up the virtual machine. It slowly wakes up, then you log in, and then you are functional. As opposed to firing up a container, depending upon the size of the image or the container, it typically fires up in a few seconds. The container by itself may fire up much faster. The application may take a little bit longer. It purely depends upon your application. So if we just look at the level of the virtual machine and the container, how fast it fires up, it definitely gives you that fast deployment capability. And looking at the way how we are looking to deploy applications more rapidly, more number of times, this is sort of the trend why it's catching up so prominent. It also gives you easy portability. As we talked about it, how I can take my Docker image and I can run it on any cloud or any orchestration framework is the same Docker image that would work across the different orchestration frameworks, across clouds, across operating systems, and that's the beauty of it. Another cool thing about containers is it also helps you minimize the impedance mismatch. How many times it happens that you build something, you're running a MacBook, it works fine in the development environment. You go to production and the thing is completely broken. Now with containers, because you are building a Docker image, because you're baking in all the dependencies as part of the image itself, when you run the container itself, it gives you that independence. It reduces the impedance mismatch between your dev and your staging and your production. So essentially your image sort of becomes the source of truth, and that image kind of goes through your production pipeline essentially, and that's what helps you cut down the impedance mismatch. And the best part about this is, this is not something, it is revolutionary in a sense that it gives you all those benefits, but it's very evolutionary as well because it is fitting very well in your existing tool chain. Whether you are using NetBeans, Eclipse, IntelliJ, whether you are using Maven, whether you're using Gradle, whether you're using Jenkins, whether you're using Amazon or Google or any cloud for that sake, or what is your existing tool set? It fits very well right in with your tool chain. I was at DockerCon a couple of weeks ago, and their whole mission is about, the Docker's mission is about, how do we build tools of mass innovation and completely get out of the way, as opposed to helping you do that mass innovation. And that's sort of why containers is so prominent. So what's sort of the current state here? Well, Docker, of course, the biggest gorilla here that people talk about it. Now Docker, people tend to forget, Docker gives you the image format, which is a Docker image, and it also gives you a runtime where you can run the containers and have a full orchestration platform behind it. OCI is something that we'll talk about in a bit, but OCI is Open Containers Initiative. It allowing you to say, okay, you can have different container formats. It's sort of a standards body under Linux Foundation, which says this is how you can have a standard image format and a runtime format, and then other vendors can comply to it. Archity or Rocket is another container format by CoreOS, and the hope is that they will eventually both be compliant with the OCI format. And in terms of the container orchestration frameworks, these are sort of the major container orchestration frameworks. So Docker by itself has Swarm, which is a container orchestration framework. Then there is Kubernetes, which is by CNCF, originally built by Google and then donated to CNCF. Then Amazon has a managed service, EC2 container service that integrates very well with the Amazon infrastructure. And then DCOS, which is by Mesosphere, built upon Apache Mesos and offered as a service as well. So those are sort of the four major orchestration frameworks. And then there is everybody, it's like a JavaScript framework. A new one comes along every day. Something that you want to watch out for is OCI. OCI is, as I said, is a foundation under Linux. It's a group, a consortium under Linux Foundation. It is saying, okay, we want to define a set of common standards for image and for runtime. So if you go to the opencontainers.org, they have a link to their GitHub repo. And in the GitHub repo, there are two particular GitHub organizations, and then there are two repos that they're talking about, image spec and a runtime spec. Pretty close to being final, literally in the next few days, weeks, it should be final. But essentially what they're doing is they're defining what is a standard way to have an image and a runtime, and then the vendors are going to be compliant with that. Okay, that's sort of my bit on containers. Second bit. Microservices. We had a very interesting discussion in the panel yesterday about microservices. So what is this whole thing about microservices? Why is it such a hot technology? Why people care about it? Well, the canonical definition typically people talk about is given by Martin Fowler. Not that he coined the term itself, but this is a very nice and easy way of saying what really are microservices. And the key parts are really highlighted over here. If you were to give sort of a Twitter definition of microservices, essentially you will say it's a suite of small services, each running in its own process and communicating to each other using lightweight mechanism, typically HTTP. So think of a classical monolith application. That monolith application has everything baked into it. Whether it's your model, view, controller, everything, your database logic, everything is kind of baked into it together. And if you were to scale that application, then you will deploy that application like one box, for example, into multiple times. So that's sort of your typical scaling strategy with a monolith. With microservices, the scaling is a bit different. You essentially take your bigger application, break it into smaller services, and then you allow each service to scale independently. Now, if it's a login service, yes, you need that to be more prominent. But if it's, think of Amazon, for example. I'm not saying that's a classical example, but Think of somebody building a shopping cart. You want more services to be able to deal with just the view-only data, but possibly less number of services to be able to read to do the checkout, because more people are likely to view the shopping cart, view the materials, than actually order it. So that way, it gives you that flexibility, the agility to scale your services independently. Why microservices? Well, first of all, it gives you those strong module boundaries, because essentially what you're doing is you're following a domain-driven approach, and you say, all right, here is my product service, here is my catalog service, so on and so forth, and then each of those services are really talking to each other using a very well-defined boundaries. That's what is called as a bounded context. It gives you the ability to use the right tool for the right job. If you're working for a big GSI company, then you would say, hey, by the way, my group is only allowed to use Java. That's saying, you know what, okay, take this square and jam it into a round circle here. So it gives you that ability to diversify inside of technologies, because essentially, when you look at these microservices, they talk to each other using REST API. And if these REST APIs are working fine, we don't care really about what's the underlying implementation. What's the underlying data store you're using? Are you using relational database? Are you using NoSQL database? Or are you even using a database? If it's all in the cache, for example. So it gives you that technology diversity, essentially. It also gives you the ability to independently deploy a service, update a service, and scale a service. So let's say a particular service has more requirements, then it can scale a lot more rapidly. And because the services are domain-driven, they have much smaller amount of logic. By the way, micro does not mean 50 lines of code or 100 lines of code. Micro really means in terms of the scope. The scope is much smaller. But it gives you the ability to really do the fault and resource isolation much easier. So something to watch for in the microservices space is CNCF, which is Cloud Native Computing Foundation. And what they're doing is they're using an open source software stack to deploy applications as microservices, because this is sort of the paradigm that people are trying to adapt and build their applications. It also says you can package each part of the microservice, each microservice by itself in a container, and then eventually orchestrate these containers using a scheduler or an orchestration platform. So essentially, the microservices and the container, they nicely complement each other. But one of the most common confusion people say is, oh, does that mean I need containers to run my microservices? Or if I'm using containers, does that mean microservices? Not necessarily. They nicely complement each other, but they're not really required for each other. This is a handy snapshot of the open source stack that is promoted by CNCF. You can look at the GitHub URL at the bottom. And it is at version 0.9.4, but it kind of clearly highlights in terms of infrastructure, provisioning, runtime, orchestration. What are sort of some of the options when you're trying to build your application? What should your stack can potentially look like? So essentially what you will do is when you're building your application, you can take a look at this snapshot as the first version that, okay, I'm going to use Amazon, and I'm going to use for provisioning, and I'm going to use such and such, and runtime, and so on. So this will at least give you a starting point to think about it. All right. Third point that I want to talk about is continuous integration and deployment. My favorite story is a couple of years back, I was in India with a customer. I asked them, what is your CI/CD story or strategy? Like, see what? I said, okay. I said, how do you go to production? I said, oh yeah, when we're ready to go to production, my lead developer, he has an Eclipse IDE open. He right-clicks on it, he generates a jar file, and he mails the jar file to the testing team. I said, okay. What happens after that? I said, okay, when the testing team is done, they mail that jar file to the production team, and it goes into production. I said, and if there's a patch? Oh, there's a patch? Yeah, sure. We generate a patch, we send a WAR file, they open the jar file, they put the jar file, and then they test it again. I said, oh, there is no CI here at all. There is no process here at all. It's fundamentally important, that you follow some regimen at least. So there is a CI/CD maturity metrics, and I would probably put that at -1 level, maybe -2 if there is something like that. So take a look at the CI/CD maturity metrics, where you are in terms of, in order to help you assess it. What are some of the tenets of CI? Well, the first is source code repository is a single source of truth. It's not some lead developer's laptop where the source code is sitting. Pick whatever your source code repository is, whether it's Git or SVN, or pick your favorite Mercurial repository, but that's the source of truth. All source code, application, test, configuration files, your provisioning files, your images, everything is checked in there. You automate the build. There is a single command that pretty much builds your workspace. There should be an ability to say who checked in at what point of time. These capabilities are available in all of the modern source code control systems. Keep the build fast. Let's make sure that it doesn't take hours to do your build. That kind of hurts your ability to innovate that much faster. There should be a TDD, or a test-driven development, essentially. So there are certain places where I know where you cannot check in a code unless you have a corresponding test associated with it. So make sure you follow that regimen, essentially. And then commit early and commit often. You don't have to wait for 3 days to do your commit and then figuring out, oh, it's a conflict. We need to go resolve that conflict. I would say once every few hours. I don't mind seeing a lot of commits in a particular day. But then, as you are reaching a logical point, you push your code out, and then you can integrate with the rest of the team. And then in the meanwhile, somebody is doing the job of testing. So essentially, what it gives you is the ability, as you're committing early and often, it doesn't get rid of the bugs, but it does help you identify them earlier in the cycle. Because you're committing more often, you're pushing more often, there is a CI/CD system that is sitting in the background that's checking out the code, building the code. It figures out any compilation errors, it runs the test, and it reports early and often. So that's sort of the important part about CI/CD here. There's a beautiful book by Jez Humble and David Farley here on continuous delivery. And essentially it says it's really taking CI, the continuous integration practice, and taking to its logical conclusion. And essentially what it means is any good build that is ready for you, it could be potentially released to a customer. Now, there is a difference between continuous deployment and continuous delivery. One of them saying, okay, the build is available as a candidate. It can be manually pushed or automatically pushed. But you can look at it, what is required for your product delivery. Now, Amazon has this service called as AWS Code Pipeline, which allows you to build a complete CI/CD pipeline for you. So for example, you can say, here is my source. Source code could be whatever. It could be in Amazon S3, GitHub, pick your favorite source code repository. Then you can say, as soon as the code is changed, it's going to build it. It's going to use Jenkins or AWS code build service, and it can use those components. Then once it's done, then you can run the tests, and then eventually you can start deploying to production. So take a look at this AWS code pipeline service. It really allows you to build a complete CI/CD pipeline very easily. DevOps, if you look at the trend, essentially, the first 3 technology trends that we have talked about have been there for a while, but there is still lack of understanding or awareness around these. So I highly encourage to take a look at that. Now, this is a DevOps manifesto, again, that was written by Jez Humble. So it's about a 15 points that they talk about what are relevant for DevOps. But essentially, if I look at it, I'm going to highlight 5 points from this. First of all, it's a reaction to poor communication between teams. DevOps basically says the teams should communicate more and more and more. You should discuss what's going to happen. Have the dev feel the pain of ops, have the ops feel the pain of dev, so that you understand what are your real deployment scenarios. It also creates about visibility between dev and ops. That when I'm building this application, I'm not going to presume where it's going to be deployed. I would like to know. What are my deployment concerns over there, how it's going to be going to production, how it's going to scale, so that the ops people can give you that feedback as well. Then, as opposed to giving somebody a README that, hey, take this README and this is how you go into production, have a script. Don't give me a readme.ascii.doc, give me a shell script. And I want that shell script to be completely automated, parameterized, whatever it needs to be done. So automation over documentation is definitely. Company like Netflix, if they can be 100% automated, if your application is more complex than that, then you can think about, hey, I may not be automated. Don't tell me you cannot automate your application 100%. It's about creating self-service infrastructure for teams. Again, go back to the example of Netflix. Essentially, any engineer in Netflix can release any feature at any point of time. They have the full capability to do that. And why is it possible is because they have an internal portal where they say, you know what, I want to provision this particular feature, I want to release this feature to this Europe West region, only in this region, and at like 11 in the morning. Hopefully nobody's watching anything at that point of time. But that allows them to provision the servers in a particular region and then do a canary testing. And if the results are good, service will automatically scale on a global level. So that's about the self-service infrastructure teams. And then last but not the least is really the product is retired only when you get out of production. All the way until the end, you really own the responsibility of the product. There's a beautiful report by Puppet Labs that has been coming out year after year. And in 2016 State of DevOps report, 2017 would typically come out around in May timeframe. But the companies who are doing DevOps are seeing 2,000 more frequent deployments, 200 times more frequent deployments. And that gives you the ability, the agility to innovate that much more rapidly. Their lead times going into production is 2,500 times less. Who doesn't want to do that? So I think, but it does require a mental change on your side. So the 5 C's of DevOps, I'm going to quickly go through them. Essentially, the collaboration between Dev and Ops, it's more communication, more visibility, more transparency. It is a fundamental culture change. One of the customers that I was talking to, they said, hey, by the way, how did we enable DevOps? Hey, we had the Dev and the Ops team report to the same manager. Now they complain each other in the same staff meeting, and the problem resolved that way. That way, there is no 2 points of contact that we need to talk to. Code everything. We talked about automation over documentation. That is fundamentally important. Again, consistency. I should be able to run the script and get the exact same result. Now, computers are intelligent, but they are dumb too. Because if I keep running the same script, they'll keep producing the same result. And I like that consistency. And last but not the least, one of the key concepts over here is, again, CI/CD that we talked a few minutes ago. One of the fundamental concepts of DevOps that you also want to understand is, with great power comes great responsibility. So in Netflix, yes, the developers have the capability to release a feature at any point of time, but they know if the feature is broken, they're going to get a pager, not somebody in the ops team, essentially. So make sure you responsibly and you own it. So this is one of the examples I read, an article I read a few years ago, actually, before I joined Amazon. Essentially, it talks about how they switched Amazon Web Services from self-hosted data center to AWS. Now, Amazon.com is running on AWS. And essentially, since they switched, AWS gets a new update every 11.6 seconds. And you can look at this. This is an article from 2014. So the figures would be very drastically and dramatically different now. They were doing literally 1,100 deployments in an hour. And something at that scale, it cannot be done. Oh, you know what? You can't ask somebody that do a deployment. It has to be automated. It has to be 100% automated. And then something what they use internally and which is also available as a managed service now is Code Deploy, on how you can automatically do deployment across a huge cluster of AWS, for example. All right, Internet of Things. Well, what is Internet of Things? Internet of Things is, think about everything around you, whether it's a watch, whether it's a broom, whether it's a microwave, whether it's a milk, it's a refrigerator. They all are communicating with each other to providing a value where you can actually make sense out of it. Something like, in this one, there are a lot of funny examples in this one, but the one that I particularly like here is $20 in my PayPal account, or I'll only brew decaf. All right? It can be dangerous in that sense. But essentially, what are the key components of IoT? What we are looking at is sensors. Name a device that is around you. There is a sensor attached to it, whether it's a GPS, whether it's a temperature sensor, whether it's a pressure sensor, whether it's a leakage sensor, and how those sensors are then used effectively to make sense out of it. Well, once you have the sensor, the data is generated. Now, that data needs to be connected to the network. And so the second part of your IoT is really the connectivity part of it. It could be using a cell phone, could be a Raspberry Pi device, could be some Beagle board, but once the sensor is there, using any of the connectivity technologies, the data is then uploaded into the network. And last but not the least, the key part over there is where the people and the processes get involved in there, where you're saying, okay, I got all of this data. How do I make sense out of this data and make my process more efficient? I was reading an article how one of the railway companies in the world, they are installing these sensors across their rails, and then based upon how much time it takes for a train to go from point A to point B, they're able to optimize the route and make the trains a lot more efficient. That's one of the classical examples of how people can use IoT effectively. But in terms of Amazon, you have a full service plane, data plane capabilities that are available to you. So you can take your, for example, any device that you care about, connect it to Amazon Cloud using AWS IoT Device SDK. Then you can have the authentication and authorization happening. You can configure all your devices in a registry. Then using the rules engine, which is sort of the people and the processes part of it, you can guide it to whatever services need to be invoked and store the data and then make sense out of it. Then you can backend it with a Redshift or a DynamoDB or whatever service is there to make sense out of it and make your processes more efficient. These are some of the deployments that are running successfully on Amazon for IoT. One of the ones that I want to highlight here is iRobot. Well, iRobot is the company behind Roomba, which is a vacuum cleaner. It's a small circle vacuum cleaner that goes around your house and mops the floor. Using iRoomba, they have this connected home initiative. And using the AWS products, they have been able to traverse 500 million square feet using their connected home initiative and cleaning floors, essentially. Another one over there that I want to talk about is Under Armour. Under Armour gives you those sports accessories and athletics. It's a pretty famous brand. I particularly love them. They have, again, a connected fitness platform. 180 million customers on Under Armour using that connected fitness platform, saying, how my garments and my fitness regimen are going to match with each other. So these are some of the examples that people are going to start looking at it on how IoT is going to change their lifestyle. So if you think about this, the first 5 technologies that I've talked about so far, I've been focused on, they have been sort of into the mainstream for some time now. Now, I'm going to switch gears here a little bit, and I'm going to start up talking about some of the technologies that are more future-looking, essentially. So the first one that I'm going to talk about is serverless. And there are a few talks at the conference about serverless, and I'm happy to talk to you about this afterwards as well. But what is really serverless? I mean, if you think about this, from the virtual machines, containers, and serverless, I'm going to compare them. This is basically how do they really look different or same from each other. Well, the first thing is in terms of unit of scale, in virtual machine, I'm using a virtual machine as a unit of scale. In containers, my application is scaling. I'm saying, okay, run this service with 5 replicas, so I'm running that many more instances of the application. If you look at your application, it's essentially broken down into multiple functions. And then in serverless, what we're saying is, the serverless is, in my opinion, a misnomer. We say serverless, but essentially there are servers running in the background. It's just that you don't care. You don't know what the server is running in the background. But a more appropriate name would be function as a service, because essentially you're saying, take this business logic, run it in the background. I don't care what, here's my Java code that needs to run. How you scale is your problem. So essentially my unit of scale in that case becomes a function. In terms of abstraction, if you look at virtual machine, we don't care about the underlying hardware. In terms of containers, we don't care about the operating system or the cloud. And finally, in terms of serverless, all I'm saying is, here is my Java application, go run it. Or here's my Python application or Node or C# application, and go run it. In terms of packaging, in terms of virtual machines, if you use Amazon, then of course AMI is your standard way of packaging your application. In terms of containers, you have your Docker image or whatever format is your favorite. In terms of serverless, we're really talking in terms of the code itself. Code is my unit of packaging. In terms of configuration, If I'm looking at virtual machine, I have to configure machine, storage, network, operating system. In terms of containers, I am mostly configuring what application containers are going to run, but I'm still responsible for their scaling. But in terms of serverless, the way it works is run the code whenever is needed and scale it as much as is needed. In terms of execution, typically virtual machines are multi-threaded, multitask. In terms of containers, multi-threaded, single task. And serverless kind of gives you that single thread, single task, but the scalability is vast, and I'll show you an example of that. Typically, a virtual machine, it has brought down, your provisioning from months to hours. It takes maybe a few minutes for, to provision. In terms of containers, it takes a few minutes to fire up your containers. And in terms of serverless, you can literally spin them up in a few seconds. That's sort of what we're looking at it. And if you look from a different perspective, how much is the length for a virtual machine? Typically, your virtual machine would run from hours to months. That much longer time it will run. If you're running a containers, typically you will recycle your containers in a few minutes to maybe a few days. Serverless, you don't care about it. You run it and then you just get out of it. You want to fire up a new function, then you fire up a new function right away. Again, the unit of cost is different. And then at the bottom, what we're showing is some of the offerings in virtual machine containers and serverless. Let's look at it from a different perspective now. If I'm looking at IaaS, Internet as an infrastructure as a service, then I'm showing in the blue color, what is it that is customer managed? And then the blue unit is sort of what my unit of scale. And then at the bottom is what I'm showing is exactly, what is the abstraction that I'm being provided to. If you look at container as a service, yes, the unit goes up. There's one less thing I need to worry about. Then if we talk in terms of PaaS or platform as a service, then yes, I'm looking at applications as my unit of scalability. And eventually, if I'm looking at function as a service, all I'm caring about is my function. Everything else is a vendor detail over there. So how does it work? How does function as a service really work? A very classical example I will show you here is with the customer reference. Imagine you take a picture, you upload the picture to S3. As soon as the picture is uploaded to S3, the bucket gets a notification that picture is uploaded. That notification can then trigger a Lambda. For example, in AWS Lambda, which is Amazon's function as a service. The Lambda code gets executed, where it gets executed, which instant it gets executed, that is completely transparent to you. And what does that Lambda code do? That Lambda code basically can take that image that is being uploaded to S3 bucket, and it can create different thumbnail sizes for different devices. That's exactly the example that Seattle Times back in the US is using it, and how they're using Lambda functions. And there are many more use cases at AWS, Amazon.com/serverless, if you want to look at it, on how customers are really effectively using serverless architecture. In terms of a broader application flow, what you would have is you would have your different devices, websites, web services. They're all coming through the internet. These are typically your clients for your application. They come into the internet. The first thing that they will hit is something like an API gateway. The API gateway is where you will configure based upon the request, based upon the URL, where should the request be dispatched to. You can have a gateway cache, or you can have CloudWatch monitoring. You can do all of those things, logging, all of that is available to you. But once you have figured out where the request needs to be dispatched, at that point of time, you can say, okay, go ahead, trigger this Lambda function. So essentially, your Lambda function needs to be triggered. That triggering could be done by a document uploaded in S3 bucket. It could be updating a table in DynamoDB, or it could be an API gateway call. On my blog, I've talked about exactly how Lambda function could be triggered, for example, by Maven. So take a look at that. Talk a little bit more. So virtual and augmented reality. So now typically, what is the difference between virtual and augmented reality? There's a book by the name Born to Run, and I'm a runner, so I like to read running books. I was talking to Ivar about this morning. The book beautifully explains how the Tarahumara tribes, which is a tribe in Mexico, how they can run hundreds of miles for days and days without getting tired. It's very immersive experience. When you listen to some music, when you're watching some movie, sometimes it gets very immersive. You feel that you are in that world, really. And that's exactly what virtual reality enables it for you. It essentially brings all the sensory perceptions around you, giving you the feeling that you are really as part of that. We recently built our house over a year, and it took us a year to build that house. My wife is a very touch and feel kind of person. One of our biggest problems was that, Arun, as a designer, is telling us, she's showing me in papers. I really wish there was a virtual reality model where she could walk into the house and then she can feel how the door is going to look like, how the bedrooms are going to look like, what the kitchen is going to be functional. So virtual reality essentially makes the reality, makes the virtual part of it a little bit more real to you, as opposed to augmented reality, where augmented reality enhances the real world experience for you. The world is real. All it's using is augmenting it by using the data that is available on the internet for you. So imagine visiting a heritage site, and you just take your smartphone over there and say, tell me more details about it. It can quickly kind of highlight some of the details that, you are in this road, and this structure was built in such and such century, and what is the history for it. All it's doing is pulling the data from the internet and augmenting your real world experience. So what do we need for virtual reality or augmented reality? Well, of course, you need particularly for a virtual reality, you need a very rich, detailed world. Because if you were to be as part of, go back to my example of Born to Run, if I were to run with these guys, in the Mexico Tarahumara tribes, then, somebody needs to build that world where while I'm running with these guys, I'm actually having that experience. I can see those cliffs, I can see those mountains, I can see those rivers, running along. You need that much more extreme processing power. Because if it's a rich, detailed world, and as I'm experiencing it, somebody needs to render that world. If I move my head from here to there, then essentially I should exactly feel, as I'm in the real world. So you need that much more processing power. Not just in the compute backend, but also on the gear that you would put on your headset. And then third part, of course, is the gear part of it. So, and the gears, again, there are different parts and pieces. You can wear a headgear, there are hand gloves, or there are rooms as well, which we'll talk. Let's take a look at AWS reInvent. We launched a whole bunch of new EC2 instance families. Particularly look on the far right side of it, where we have very high graphical intensive units that are available to you. So we can give you all those processing capabilities that are available. We definitely love compute at AWS. So depending upon what your requirement is, you can really build some very fancy applications using these EC2 instance families. In terms of the virtual reality gear, what are the key components that you should look at? Well, the first is, of course, a headset. And there are a variety of headsets that are available to you. So you put a headset on, it's a very immersive experience for you. Then, of course, you need some sort of a gloves or some sort of a device with your hand where you can touch and feel, and then it'll tell you whether it's hot or cold or make a grip and things like that. And last but not the least, there are immersive rooms where you're not wearing a headgear, but you are in the room and there are screens all around you, and then you have your sensory perceptions on your arms, and you can get a complete feel of it. All right, let's switch gears a little bit more forward thinking, artificial intelligence and machine learning. So artificial intelligence is a broader concept where we are looking at machines and then they can do smart things for us. That concept is not new. That has been there since 1960s if you think about it. That's sort of when the term was originally coined. Now machine learning is what is making AI a bit hotter these days. Think of machine learning as an applied artificial intelligence. It's a subset of artificial intelligence. So everything that is a machine learning is an AI, but there are other concepts in AI that are not directly applicable to machine learning. Essentially what machine learning is saying, okay, we want to take the data that is available, give it to the machine, and let's make the machine make a decision for us. And then there is deep learning, which is sort of cutting edge of the cutting edge, going really deep far. And it's really taking those neural networks into account, and it can do the thinking for you. Think about the case where IBM Watson, won the Jeopardy round. It's basically taking all the data that is available on Wikipedia, and now when the person is asking a question, is understanding the question, the human is asking a question, is understanding the question, parsing all that data within the given amount of time, is responding back to your request. Not only back to your request, but is actually winning the round as well. So some of the APIs that I'm particularly fond of is, look at Amazon Recognition API. It's basically a deep learning-based image recognition. Lots of different ways by which you can do image recognition here. You can start detecting object and scenes over there. Oh, this is a biker. I want more images. I'm a biker or I'm a runner. Give me more images of runners. I can start doing facial analysis. That can be very useful, for example, for locking and unlocking your security credentials, whether a laptop or a house or things like that. You can start doing face comparison. You can start doing facial recognition. Oh, this is a girl. She's smiling and her eyes are open. Show me more pictures like her. So you can start looking at some of those things and start getting more images like that. Binder is, for example, one of the Amazon customers, and where you can upload images and do collaboration very easily. As opposed to users filing the images, Binder uses Amazon Recognition and easily helps you cut down your number of hours spent on the manual labor. Amazon Poly, again, a managed service. Essentially, you give a text in and you get a lifelike speech out. Now, in this case, for example, all I'm saying is the temperature in WA is 75 degrees F. Now, that makes sense from the written perspective. But is that how I would say it? No. I would like to say it is the temperature in Washington is 75 degrees Fahrenheit. So that whole context sensitivity is baked into Amazon Poly. So you just give it a text, and it gives you an MP3 file back that you can play it back. How is all this being used for actually building applications? Duolingo is, for example, one of the customers. They are using, it says, okay, you can take one language and translate it into a different language, and then it can start speaking it out. And then last but not the least, we have Amazon Lex, which is sort of the power behind Amazon Alexa. And that, again, is available as a service now. So this is a classical example where you can use your cell phone to talk to a bank, say, what is my balance? Are you looking for a checking or a savings account? So you can start having that conversation. And then once you have done the conversation, it figures out what it needs to be done, then it can use AWS Cognito service to do your authentication. And once the authentication is done, then it goes behind the service, talk to a serverless architecture, gets the data back to you, and then returns a response back to you. Now, that is exactly the use case, how it is done at Capital One, for example. So I would recommend taking a look at this, how they're using Lex, Poly, all together to build this use case. Real machine learning, there are several customers that are doing real machine learning on AWS. The one that I want to highlight here, three that I want to highlight here is fraud.net, which is a crowd-funded fraud detection platform. Netflix, of course, run their recommendation engine on Amazon. So you see the Lolomo, you go to netflix.com, list of movies on your page. That recommendation is generated using AWS. And then Zillow, which basically gives you estimates about your real estate in US. So you can go to Zillow.com, look into a particular neighborhood, it will tell you the price of a particular house. And that recommendation is built using Apache Spark, Redis, and all the machine learning platforms on top of AWS. Let's talk about blockchain. That's sort of one of the last technologies I want to talk about here. Blockchain is pretty bleeding edge. There's still not a lot of understanding around what blockchain is about, but if you think about it at a very high level, it's a distributed database that is continuously reconciled on a regular basis. It's not stored in a central location. It's literally distributed across the network, but is continuously growing. Think of a Google spreadsheet. In Google spreadsheet, it's pretty cool because you can share between different people. Now, if you want to think about blockchain, think about that Google spreadsheet not sitting on a Google server, but now that Google spreadsheet is distributed across all those hundreds of nodes where the blockchain is configured. So that way, there is no single point where somebody could tamper it. There are hundreds of nodes where it needs to be tampered with, which is not easy. There is no single point of owner, so there is no lock-in. All those members that are part of the blockchain are the owners essentially. And each change that you make, the reason it's called as a blockchain is each change that you make is created as a block and put it as part of a chain with a link to the previous block. And that is owned by the entire community of blockchain. Now, the important part to understand is it's not a new technology, but it's just applying existing technology in a new conceptual way, a new way of thinking. This is a broader diagram in terms of what blockchain looks like. So, Bitcoin is basically what brought it into prominence, what blockchain is about. So you start a transaction. The transaction, goes through the entire network of nodes where the blockchain is executed. Once the transaction is verified using PKI infrastructure typically, then a block is added to the chain, and that's the name blockchain comes from. Now, the important part to understand is there is, in terms of a cryptocurrency, for example, there is no monetization that is involved in this. The currency lives in the network and is owned in the network. Now, yes, there are Bitcoin ATMs where you can say, I got so many Bitcoins, give me dollar money for it, but that's not a typical use case for it. So what are some of the use cases? Smart contracts. Think about an insurance contract which is sitting in the network, in the community, and it can automatically be fulfilled once the requirements are met. Think about sharing economy. Uber and Airbnb are all about sharing economy. It can really take that sharing economy to the next level by using the blockchains. Crowdfunding. We have learned about Kickstarter or GoFundMe. Think about crowd-funded venture capitalists. Governance. Some of the presidents complain, even if they win, that, the election was not fair. If those results are shared on a blockchain, they're going to be completely transparent, completely distributed. Nobody can complain or blame that the elections was not correct. I run a solar panel on top of my house. It'll be beautiful if there could be a neighborhood microgrid where we can say, hey, by the way, I got excess power over here. Instead of selling it to PG&E, which is my electricity provider, I'm going to sell it to my neighbors. And if they have more power and I need more power, I can build that community right there itself. Stock trading, another example. So there are lots of uses of blockchains. What are some of the frameworks that you should be looking at it? Well, the three primary ones that people typically talk about is Ethereum, Hyperledger, and Monax. And there are big vendors behind each of these. For example, Ethereum is by Ethereum Foundation. Hyperledger is by Linux Foundation. They are both offered as service on IBM and Microsoft clouds. And there is Monax, which is available on AWS Cloud Marketplace. You can also set up private blockchain. So for example, multi-chain is where you can easily configure a private blockchain, or Infosys or PwC, they have their private practices around blockchains as well. At AWS, we have also worked with partners to configure this as part of your network. So the technologies that you're seeing are already existing as part of the AWS infrastructure. We're just using those technologies and applying them in a different way to create a blockchain infrastructure for you. And last category that I want to really talk about here is chat ops and offline first. Now, I wanted to kind of get a user poll in terms of what are the top 10 technologies. So I tweeted this on 31st January. There were a lot of responses to this particular tweet. And so these two technologies are essentially gathered from the user feedback. So what is chat ops? Well, chat ops is, if you guys are using Slack or HipChat, how it takes people, bots, and tools and build an automated workflow where things like, this looks good. A chatbot is sitting at the back end, is looking for that thumbs up signal or some sort of a visual cue or a verbal cue, and then it goes ahead and does the deployment for you and sends you a message. So it simplifies your workflow, and it also generates transparency, essentially. The new term for this is called as CDD, or conversation-driven development. Slackbot, HipChat, those are some of the concepts over here. An easy way to implement is running in as a serverless architecture. What are the high benefits here? Higher transparency, shorter feedback loop. So that's something definitely you should consider. And the last one that I want to talk about here is offline first. Lack of network connectivity on your device, it should not be considered as an error exception or error as an exception. It's very important that you build your application to behave in an offline first way. Now, you may say that my application only works in a connected way, but your application should still be ready to behave in an offline first, and in case there is connectivity, it can act accordingly. So I think that's sort of the way you want to think about it. And if you read about the progressive web apps, they define a baseline, and then on top of baseline, they say what capabilities are available, and then they start building your app accordingly. So you could have zero reception, you could be going through a tunnel, you could be in a geography where there is no wireless connection. So lots of ways, lots of factors would kick into why lack of connectivity is not an error condition. Some of the key concepts over there you want to understand when you're building an offline first application is, yes, you have done a lot of changes to your application when you're offline, but when you become online, what happens? Synchronization needs to happen with the backend server. The conflict resolution needs to happen. The security credentials need to be translated accordingly. So those are some of the things that you really need to be aware of. Some of the frameworks that you are looking at over there is Hoodie, Ionic. You have worked with Couchbase Mobile for 18 months. I really enjoyed it. Couchbase Mobile really gives you the ability where it has offline storage on your device, and it does synchronization and offline capabilities with the backend server very easily. So just a quick summary. These are some of the technologies we talked about. If you are not actively looking at them, I would highly encourage to go. Once you go back, over next 10 months, pick a technology and say, what? Oh, this month I'm going to read an article about this. I'm going to write an article about this. I'm going to play with this technology. Make yourself a richer person technology-wise. Thank you.